Hello, everyone. My name is Jimmy Constante. I'm a student of the course Digital Data Communication, and this is the final project of this course. The title of my project is Software for Link Budget Calculation. All right, let's start. First, we have a problem, right? This problem is engineers doing math calculations for determine viability for some projects, and specifically in networks and communication technologies. We do have a lot of problems as slow calculations, slow viability when you're trying to do a project, and of course, a lot of manual errors that we commit doing calculations. So, the solution for this problem is develop a Streamlit web app for link budget calculation. All right. So, for this project, we are going to use Python to develop the application and the Streamlit framework to show our results and also for input all the information to check if a project of communication, whether it's Wi-Fi, microwave, and fiber optic, is viable to make it real. Um, or theoretical framework overview. So we are going to need many variables to check that. So we're going to need the some parameters to check if a link is viable. So we are going to determine the link viability, and we're going to do all the math in our system to check if this project um, that engineer is doing is viable or not. So we are going to need some parameters for this. Um, Parameters as frequency, distance, transmit and receive gains and losses, noise, and sensitivity. So the first one that we have for our project is the Wi-Fi. All right, the Wi-Fi budget model, which includes for doing the math of this one, we are going to need to make calculations of the free space path loss, the noise, the receive power, and the margin and the Shannon capacity. So for the most important calculation of this one is the margin. Why? Because this one is going to determine if uh, the signal and the network of this communication is going to be viable to do it real. So we need a positive margin to make this project viable. Okay, so the next one is going to be microwave uh, budget model, microwave link budget model. For this one, we're going to need the same free space path loss, uh, the atmospheric attenuation. So for this one, we have some limitations, but we can improve these limitations in the future. Um, but it's a good one to analyze with the basic parameters that we are going to have. For example, we can right now check as well that this one rain loss add uh, noise to our model. So in the future we can consider these variables to improve this model. All right. And for the last one that we're going to analyze and we have in our project is the fiber optic link budget model. For this one, we're going to calculate the fiber attenuation, the receipt power, additional losses, and of course that we're going to calculate the link viability through our margin. We are going to need a positive margin for confirm the link viability of this one. All right, so our functional requirements, we have our RFO1, that we have to select the communication medium, which we have three of the explained. They are the Wi-Fi, the microwave, and the fiber. So all of these we are going to choose in our project in our interface. The second one, the input technical parameters. We have to put all the parameters as frequency, distance, gains and losses, sensitivities. Okay. And for the RFO3, we're going to calculate the path losses, the receipt power, the leak margin based on the appropriate model, which is going to be one of those three that I mentioned. And then the RFO4, we're going to calculate the noise power, the SNR, and the channel capacity for wireless, media, and microwave. And for the RFO5, we are going to indicate the viability based on the calculated margin and receiver sensitivity threshold. All right. For the RFO6, we're going to generate graphs of the received power versus the distance to check and visualize the signal attenuations behavior. And for the RFO7, we're going to estimate the theoretical maximum distance at which the link remains viable based on the power model. And for the RFO8, we're going to present a text summary of all compute results with units and two decimal places for clarity and reporting. Okay, so this one is going to show uh, all these results more professional. The non-functional requirements is going to be simple user-friendly interface, result display with units and two decimal places, input validation for minimum and set values, um, local execution using Streamlit framework, and modular reusable code structure. Uh, the For this, we're going to or in our implementation, we have core technologies. We use Python as the primary programming language, and Streamlit, which is a framework for a web application with a graphical interface, and NumPy using for the math of our project. For the visualization and utilities, we use Matplotlib to plot all the graphics, which are receive power versus distance graphs. Of course, the libraries we use to check the units and everything, and of course, our model structure is going to divide it in by app point 5, that is the user interface and routing. The Wi-Fi is for make the calculations of Wi-Fi. The microondas for the microwave. The fiber or the, f- the fiber at point 5 for the fiber, and the graphics for make the reusable visualization functions for the graphics. And then our validation results, we can have an example right here, uh, of viable links, and then for each case, for the Wi-Fi, the microwave test, and the fiber optic test, um, the graphical analysis, we have the received power in dBm versus distance in kilometers, and this is going to be plotted for the Wi-Fi, the microwave, and the fiber optic models, illustrating the signal attenuation and helping users to interpret the link viability. As conclusions, we have the first one and the main one, which I realize is automation reduces manual errors and accelerates analysis, because we can uh, also make a database and save all the information and analyze our information if we want to have an history. Um, or link margin is a direct indicator of a link viability. Uh, of course, our graphics facilitates understanding of the power of the decay of the power. Um, for the future, we can do satellite links and consider Fresnel zone of stop obstacle losses. Um, of course, that we can in the future as well do PDF sports, technology comparison, requirement profiles, um, everything that could improve our project. All right. That should be all. Thank you so much for your attention. Bye bye.